Thank you. Oh, thank you. Yeah, I was wondering how to hold three things at the same time with two hands. All right, hello everyone. So the title, why won't anyone think about the children? How does this clicker work? Probably turning it on, holding it the right way. Wonderful. Okay, so here's basically the mental model that we have when we're using our phones. There's us, and there's our phone. If we want to extend it a little further, there's lots and lots of internet that it gives us. Now, from the point of view of the apps that are actually running on the phone, the mental model looks more like this. So there's all these sort of dizzying array of sensors that are filled with data and all sorts of identifiers. And there's a huge number of ads and analytics companies, as well as just random IPs that I can't even find where they go to, but usually they stop tracing the route somewhere in China. And some game is collecting all this information and just sending it out. And why, and what's the motives, what's going on. Well, one of the things that's insidious about the way that this is done is because when we're using some game, there's us and our personally identifying information, our PII, as I'll call it. It is being sent when we use some game to an ad company. Now this ad company further learns behavioral information as we're using it, because they're learning that we're at some location, we're playing some game, we're doing something at a particular moment in time. And okay, that's fine. But then when we start using some other game, what ends up happening is that the same identifiers, and these could be anything like a name, or they can be a serial number on the phone, or just a random number that's assigned to the phone, these same identifiers allow these two pieces of information to be linked. Now you had this original data and this new data, and they're both linked by the fact that this identifier uniquely identifies a user at a particular moment in time. And the result is what's called the dossier effect, where a huge amount of information is just collected for the sake of collecting it and build to an ever-growing dossier about everyone on Earth. All right, maybe we should protect children from this. Maybe we as adults can opt in and say this is fine for us, but children, we have this mentality that they're not able to make informed decisions. That's why they can't vote and so forth. So maybe we should protect children and let them decide when they're old enough. And in fact, in the United States and Europe, they do. So the European Union's GDPR regulation has provisions for children. The United States has a law called COPPA, the Children's Online Privacy Protection Act, which is from 1998 and has very strong penalties, $40,000 per violation. It's been enforced. There's been millions of dollars of fines for behavioral advertising, for example, for doing this sort of tracking, for sending location information and so forth. So there are actually laws on the books and in places, in some jurisdictions, are being enforced. And if you've ever seen the phrase, you must be 13 years or older to use the service, this is the reason. It's because it's far easier to just say, we don't support children, than to actually follow the rules of the law, because there's a lot of laws when it comes to collecting information. It's easier to just say, you're not allowed to use our service, and if you end up using the service anyways, well, we didn't know anything about it. So what we did is we built a tool to help us measure compliance. This is myself and my friends and colleagues at the UC Berkeley and the International Computer Science Institute. We were building a tool to help us measure the compliance with the law of COPPA. And so this is what our experimental test rig looks like. It now looks a little more sophisticated. It's a little more organized. The wires aren't as tangled. But basically, we're running games on phones. And at the first round, it was hard to get grant funding because we just wanted to buy a bunch of phones to play games on them, and they were very suspicious for some reason. But basically, what we're doing is we have a pile of apps, and we run the apps, and then we get a pile of reports. So very, very simple, and then we get free beer by coming and giving this talk. So collecting the apps was easy. Basically, Google has a program called the Design for Families program, and you opt in. As an ad, or as a company that's producing a game, you actually say, I am making a child-directed game as a positive step of announcement. And you're given information about the law and what you have to do under the law. So you're aware of the law, you're given notice about the law, you consent to the law, and you make a positive statement saying, yes, this is a game for children that I am putting out there onto the Play Store. So basically, we collected about 6,000 games for this program from about 2,000 different developers, corresponding to 4.5 billion installations. And this is a lower bound. It would say 10 to 50 million, so we said 10. And we summed up all the lower bounds. We got to 4.5 billion installations. 130 with Princess in the title. But the question is, who's going to actually play it now? Because we have all these 6,000 games, and who's going to actually spend all day playing them? Because they're not that fun, it's pretty miserable work. Undergrads. So we hired some undergrads and we paid them minimum wage, and they played games all day. But the thing was, it was still really tedious, awful work. And we wanted to play the games for about 10 minutes each, so that's 6 an hour. There's 6,000. That's a lot of undergrad hours. So we started to use an exerciser monkey. And the idea of the exerciser monkey is that it just randomly clicks and swipes, and it doesn't have any context, and it doesn't know what it's doing. It just interacts with the phone. And it turns out the exerciser monkey is about as good as the undergrads when it came to our goal, which was contacting advertisers and seeing what information was being sent. So we tested it across the two. We found the monkey was working just fine, and then we just switched entirely to the monkey. So now we have a whole lot of phones running games on cables connected to a computer that's running them, simulating random UI events and making them talk to the internet. And we're just seeing who they talk to, and we're seeing what data is sent. If you know what I mean by TLS, we're man-in-the-middling that, so we're actually decrypting all the traffic that's being sent out of the network by using fake certificates. And we're basically just then looking at what goes and seeing what we see. All right. What's nice is that these are all for actual violations. This is not a case that it could collect location and it could send it. This is us measuring it. We did the experiment. We saw that they sent location and so forth. So that's what I'm going to be talking about now. So the first observations. Many violations come from third-party libraries. A third-party library in software is just code that gets included with some other code, and the result is that it adds extra features. So for instance, the thing in charge of running a game engine can be a third-party library, or these ad companies are a third-party library. You just include this library of functionality, and then now your program also does these extra things. It turns out that most of the privacy violations were coming from third-party libraries. And one of the things that all of these companies have in common is that they've all included in their terms of service language that just basically says, don't include us in games directed at children. So they're basically saying that if you include us, it's the game maker's fault. We're going to show ads to kids, but if you actually show them to kids, it's your fault for including us in your game. Right? This is all buried in the terms of service in some deep paragraph, and it's effectively a contract between the ad company and the game developer. And the important point here is that these libraries don't have a COPPA safe mode. These companies are saying, we do behavioral advertising. That is our business. If you include us in your game does behavioral advertising, so therefore don't include us in a game where that would be illegal in your country. And there's no way of turning it off or anything like that. So just the mere act of including them is, and I love using the word probably because I'm a computer scientist and not a lawyer, a violation of the law. And it is a prevalent problem. So as I said, we had about 6,000 apps or so in our Design for Families dataset. You can see there are a lot of apps that actually have this problem, that are including libraries that they just straight up should not be even including. And originally in our paper, we had a random sorting for this, and Supersonic was listed first, but it wasn't sorted based on any of these columns. Somehow the company that owned Supersonic found out about us, and their lawyers sent us a letter, which we, just felt so great. Letters from the lawyers. All right, observation 2. Even when a third-party library does have a COPPA safe mode, it's often not correctly used. So for instance, Facebook allows you to set a COPPA flag, and we found 75 apps set COPPA equals true. Now this means that, we looked it up, this is the correct behavior. You should not be doing behavioral advertising on any data that we send. They still send identifiers and they still send data, but they also say, but don't do anything with this. Don't look at it, or I don't know how they should interpret it. It's still being sent. 342 set it to false, so explicitly said false. So far more were setting it incorrectly. 27 had both at various points in time, and the vast majority just said nothing, right? So if we wanted to be generous with Facebook and how they respect our privacy, we could say that 27% of the apps are failing. Unless there's an explicit COPPA equals false, Facebook will take the utmost precautions with our data. Of course, in reality, 94% of the apps of these children apps are failing and not setting this flag correctly. Observation 3, where are your children? So COPPA was amended in 2013 for geolocation-based apps, and there is no exemptions for this. It requires verified parental consent. They suggest a letter in the mail. So not what is 7 times 13. They want a letter in the mail. So anytime he got verified parental consent would constitute a violation, because there is no possible way that random swipes on a phone constitute parental consent. We found that of the 6,700 declared a location permission, what this means in Android world is that they have the ability to call functions that will give them the location. They don't necessarily call the functions, but they're allowed to. It's just a way that they control what apps can do on the system. We saw that 235, so 4% of all of the children's games that we were measuring, actually obtained the location from the device, and further, 184 sent it. So most of the apps that obtained the location sent the location to some ads or analytics company. And we've been narrowing this gap. So we saw that some were accessing it, but weren't sending it. And so we looked at those particular ones and we're like, do they have some ad library in common? And sure enough, they did. And we're thinking maybe that ad library is somehow hiding this transmission of data that is in violation of the law. So one of the examples is from Startup. So we found this interesting looking string in the packet, locations equals, and then some base64 object. Base64 isn't important, it's just how we do things on the internet for historical reasons. What you do when you see base64 is you decode it, and usually you end up with something that looks like text, or looks like information, or looks like something useful, or you end up with just binary data, like a picture or something. What we saw instead was weird. It was like mostly punctuation. It wasn't like, it had frequency, it had information to it. It wasn't random, but it also wasn't meaningful. And I won't go through all of the details, but what they were doing is they were taking the location and adding encryption key, encryption key, encryption key over and over and over, as well as the name of their company's startup over and over and over and over. Now, this was military-grade cryptography in Napoleon's time. However, it is no longer how we should be doing crypto, even if you're doing it for evil purposes. All right? So keep that in mind, please. Now, others actually just use modern cryptography, and we found them the same way. We're like, what ad library isn't getting caught by our instrumentation? And sure enough, then they just put the encryption key right in the source code of the program. So you have to be a reverse engineer to find it, but it's not that hard to find. You just find these long strings that have a certain format, and then sure enough, you can start decrypting their additional way of obfuscating their transmissions of location. Observation 4, why are so many apps sending MAC addresses? So a MAC address is a number that uniquely identifies network hardware. It's how two pieces of hardware at the network level actually send a little bit of information to the next step. So your phone has a MAC address, your Wi-Fi router has a MAC address, all the routers on the way through the internet as your information goes, they all have MAC addresses. Anything that wants to interface to a network has a MAC address, and it uniquely identifies that particular hardware. And we found a lot of apps were sending out MAC addresses. And we're wondering why, because there's no MAC address game. It's not useful information. Well, here's an example. This is from Polefish. What we see here, they're not only sending the MAC address of the phone, the MAC address that the phone's connected to, they're sending every MAC address the phone can see. So every Wi-Fi hotspot that the phone notices around it is being sent, along with the name of the router, so the SSID, the name of the wireless hotspot, the frequency it's running on, the signal strength. It's just sending a full war driving report of everything around it. Why is it doing this? It's also sending the IMEI, the Android ID, and it's just terrible. Why is it doing it? Well, it turns out that the internet has a map of every MAC address and where it actually sits on Earth, because routers don't typically move around. And what happens is, if I'm in a place and I know my location, and I can say, I see these MAC addresses, suddenly, that means that these MAC addresses are at this location. And later, we come back to this idea of linkability. These data are now linked. And later, when I don't have my location, but I do have a MAC address, I can say, what is my location? And I can get it only from the MAC address. Right? So the internet knows where routers are. Routers don't really move around. And this is why we see a lot of apps for sending MAC addresses, because it's sort of a way of sending location without actually getting caught for sending location. What else have you got installed? Observation number 5. So this you can't read, but it's a list of all of the apps the phone has installed. So the Android platform does not safeguard this at all. Any app can just get the list of other apps installed. And I was wondering, why is it that they're sending this. We were trying to figure out for so long, why are they sending all of the apps installed? And we were coming up with ideas about what this might be. And then we finally realized, why don't we just look at their corporate marketing material? And then we can understand why they're collecting this information. And so this is one company, Skydio. They have this is for the NFL, so they have some sport thing, and there's which team is the most popular based on installations of their corresponding app. My favorite part of this is this text. Skydio uses our panel of 850 million unique mobile devices to survey fans. Right? This is like an opt-in thing, right? 850 million people opted in to having all of their apps sent to this company. And think about the rich demographic information that you could learn from just what apps you have installed. Political affiliation, sexual orientation, age, health information, gender. Advertisers understand this. One audience, custom audiences built just for you, also collects all of the packages off the device. Packages are apps. Pollfish, we saw the packet of that earlier. Here they offer custom polls. You can select all sorts of different demographic criteria and give polls directly to a targeted microgroup. We looked at the data going through. This is the company that was sending the MAC addresses of all the Wi-Fi hotspots. It was also sending the packages of the apps installed on the phone, and we think that that's how they're building this. In our mind, it seems like a pretty easy proposition. You get 1,000 people, you find out their apps, you use machine learning to build a model, and then you can expand that model to millions. And that's my belief of what's happening here, although all I know is from their corporate marketing material. All right, the last observation. Are free, libre, open source apps better? Free software, open source software, are they actually better in a measurable sense than these so-called free apps? These nominally free, these free of charge, these free as in beer apps? Well, we can measure it because there is a library of open source apps for Android called F-Droid, and we downloaded them all and we ran them in the same environmental setup as we did for our Design for Families apps. And here's a cross-by-cross comparison. 5,800 Design for Families apps, 1,200 F-Droid apps. These are how many just talked on the internet. So basically, almost none of these open source apps even use the internet at all, whereas the majority of children's games are actually talking on the internet to various companies. These are the ones that send personally identifying information, either identifiers that allow you to track a user over time, or location, other sorts of information like that. Again, the majority of children's games, we're down now to 30 open source apps. These are the ones that sent the advertising ID, which is an identifier that's designed to be used for advertising. Again, the majority of children's games, 0 of the open source apps. And what I want to point out is that these open source apps are not children's games. The ones that were sending location, they had icons like this, where you can understand why they might be accessing your location, as opposed to just a game that has really no business collecting your location. And we found one app that was actually sending Wi-Fi MAC addresses in the open source set. We're like, wow, okay, so this app is actually sending Wi-Fi MAC addresses. What the hell is happening? Well, it turns out it was the Let's Build the Wi-Fi MAC Address Map app. Because that's actually useful, right? If you don't have GPS, it's actually a useful service when it's being used for you and not being used for some advertiser. All right, so in conclusion, where do we go from here? Well, we're missing a bit of transparency. So this is part of the work of sort of exposing this behavior. All of this was just happening, and then we sort of like turned the lights on and were disgusted at what we saw. We made a website, appcensus.mobi, where we actually have reports so you can look up your favorite game, like Pregnant Princess Baby Birth. And you can, I know, and you can't see it, but there's little footprints here. It's really, this is a children's game. Like, when I picked this example, I didn't know that was the icon. You can see the report that we produced as a result of it. This is in the, like, oh, think about the children. So it's been in the papers. And an honor in my life, I was interviewed on the CBC, and I've been listening to them all my life, and I was just so thrilled I was on Spark, and the interview's online if you want to hear it. We also went to Google and said, here is a list of companies that are including SDKs, including libraries that aren't allowed by the terms of service to be in there. And they're in your DFF program, in your family program. We just gave them all of our data and said, not all of the data that says this might be, or this might be sending data, these are the ones that are including libraries that shouldn't be included. Definitively, this should be stopped. And we found one particular example, which was Tiny Labs, which was basically the worst one that we had saw. They included every ad library that was available. And so we used it to test, because it was a great way of testing our system to basically test all of them at once. And Google responded saying, these apps aren't designed for children, but families in general, adolescents and adults and so on. So, case closed. Well, we were wondering, how is it possible that we had this idea that they were, designed for children? Because when we went to their website, Racing Games for Kids, children love it. The levels are designed specifically for children. It's just, I don't know where we got so misled. I don't know. Thankfully, the Attorney General of the state of New Mexico agreed with our interpretation of it. And this is quite recent and why it was covered in the New York Times. And so we'll see where this ends up going. Tiny Labs games are no longer on the Google Play Store as a result. So science with impact. And in conclusion, something we can all do. Support open source software, use open source software, contribute if you can program open source software. If you like programming for fun and you make a game, just make it free and put it out there. Don't try to make pennies selling ads to kids. All right, I'm happy to take questions.
Thank you. Oh my God.